Yeah, so thanks for having me. This will be about module federation, and we talk about some advanced use cases. And all of this is about, obviously, about micro frontends, isn't it? To put it in a nutshell, when we talk about micro frontend architectures, we talk about a huge front end that is somehow subdivided into tinier front ends. And we do this for one reason, namely to assign autarkic teams, autonomous teams that can work on their own, that don't need to talk too much to each other, that don't need to coordinate with each other. Teams that can just ship their new source code when they are done. Or to put it in another way, it's all about bringing back the agility of small teams, even though you have a huge overall software system. The thing, however, is that micro frontends are first and foremost about scaling teams. I think the example in the beginning already showed this. It's first and foremost about making sure that a lot of teams can work in parallel in a very autonomous way. However, unfortunately, this guy is not a fan of micro frontends. This guy, the guy with the money, your customer. Your customer is not interested into micro frontends at all. I'm very sorry. All they want to have is one integrated solution capable of everything they need. And so somehow we need to integrate all those moving parts, all those different micro frontends in one common hall. I call this common hall a shell. And that means we need to do all of this at runtime, because remember, everything is separately built, compiled, and deployed. So the runtime is the only time where we can grab all those moving parts and integrate them. However, runtime integration is really difficult. People try to do something like this for decades, and people have found out about a lot of workarounds for making this work. Workarounds like going with iframes, or workarounds like loading web components on demand. However, all those workarounds have been a bit tricky. You needed to write a lot of infrastructure code, and normally your framework did not help with this. And that's why I'm really happy that since about 2.5 years, we have module federation. Module federation ships with Webpack, which is quite a common build tool. Perhaps it's the most used build tool out there. It has several million downloads a week. And with module federation that is now a part of it, we can easily grab over to another application and load something from it. We can do this at runtime. We can grab a component from over there, or perhaps just a function or a module. This really happens at runtime and is as simple as this, as simple as a dynamic import. And obviously, this makes integrating all those separately compiled applications a piece of cake. And while this is quite easy, at the end of the day, when you start working with all of those features, several questions come up, several quite difficult questions, like how shall we deal with version mismatches? What can we do if we have different versions of the same framework or the same library? Another question is, shall we stick with a monorepo, or should we go with multiple repositories? Or things like, how can we dynamically load everything? How can we load something we did not even know at compile time? Perhaps we did not even know the number of the micro frontends at compile time. That means we need a very flexible kind of code. And another question is, how shall we deal when we have multiple frameworks or versions? How can we build something I'm calling a Frankenstein monster? All those questions will be answered today. And to get everyone into the boat, I'm starting with the topic 0. You know, as a good software developer, I'm starting counting at 0. Point 0 is a 101 for module federation. Just a little tiny amount of slides to get everyone into the boat. Before we start, let me introduce myself. I am Manfred. I am a trainer and consultant for Angular, and I'm focusing on Angular for enterprise scale software development. In this role, I'm visiting a lot of companies and I'm helping them with consulting and workshops. Besides this, I'm also quite connected to Google and to the Angular team. I live in Austria. I do a lot of stuff in Germany. And I'm always happy if I can work together with people around the globe, which is quite easy nowadays because we are allowed to fly again. And meanwhile, we are used to remote technologies for some reason. I don't know why. Okay, so let's get started with the primer, with the Module Federation 101. The thing is, if you want to implement a micro front-end architecture with module federation, you subdivide your applications into two different roles. The first role is the shell, the micro front-end shell that loads other micro front-ends on demand. The official term in the world of module federation is host. And the second role is the micro frontend itself, the micro frontend that is loaded into the shell, into the host, and this is called remote officially. Both roles can be configured with module federation. You just need to enter some lines of configuration code to your Webpack configuration. When it comes to the shell, for instance, you need to map URLs pointing to your remotes. You can say, well, this URL mfe1 points over there to this separately compiled and deployed application. And every time I'm importing something from it, in real, I want to import something from over there. A component, a module, a function, something like this. And over there, you can expose files. Exposed files are files you are allowed to load into another application. And normally, the consumer, the shell, is not interested in your folder structure. They are not interested into the fact that something is located in A/B/C. And that's why normally you are defining an alias for all those exposed files. Just a short alias the consumer needs to know about. And after that, something beautiful happens. I guarantee you, you will love it. After that, all you need is just a dynamic import using the short names, the aliases, to point over there to grab something from over there. And the best of this is your framework, Angular, React, Vue, Svelte, something else, does not even recognize that something special is going on here. Your framework does not recognize that you load something from a separately compiled and deployed application. From your framework's perspective, this is just ordinary lazy loading. However, Webpack and Module Federation know underneath the covers that something special is going on, and they take care about grabbing it from over there. And this is beautiful. Because of this, you don't need any tricks. You don't need any workarounds. You don't need to tweak your framework. You just use your framework as is, and Bob's your uncle. Also, you can share libraries. Perhaps you find out that you are using Angular, but also some micro frontends are using Angular. And in this case, of course, it makes sense to download Angular only once, to download it once and share it. It does not make any sense to download Angular 10 times just because 10 micro frontends need Angular. Just download it once and share it. And to make module federation do this trick, just configure your library, your package here as a shared package. If you want to go with Angular CLI, you need a little tiny trick because, you know, Angular is abstracting the infrastructure away. The Angular CLI is just shielding you from all the nitty-gritty details. Currently, they are using Webpack, but normally you don't even recognize. And so you need a little tiny trick. You need an add-on. I've written such an add-on. You can ng-add it to your application. This also generates a configuration, a Webpack configuration. You have to adjust it, and then you start your application, and that's it. This is the way of working with Angular. If you work with a different framework, then just adjust your Webpack configuration. Just go with Webpack and adjust the configuration, and that's it. Okay, let me show you all of this as a demonstration. In this first demonstration, I have a micro frontend. It runs here on localhost 3000. Let's zoom in, localhost 3000. And it's within those red dashed lines, within those red dash borders. And then I have a shell. And when I'm clicking here on the flight link, then immediately the micro frontend is integrated here in a seamless way. The user does not recognize that something special is going on, but nevertheless, we are grabbing over to localhost 3000. By the way, here we are on localhost 5000, and then we are loading this component. By the way, having different boards like 3000 or 5000 is not a prerequisite, not at all. However, in this demonstration, this proves that we are really talking about two separately compiled and deployed applications. They did not know each other at compiler. Let's have a look to the network tab. If we look to the network tab, if I'm clicking here to flights, then we see that suddenly Webpack starts to load some metadata from over there. The remote entry.js is just a bunch of metadata that informs about the micro frontend over there. And then we are loading the bundle. Just one bundle with this very component with the red dashboard. There is no Angular loaded, no additional framework loaded, because it's already there. It was already loaded by the shell, and now it's shared. So it's really a piece of cake. You don't need to load a lot of stuff, just what you need on demand. Let us have a look into the source code of all of this. Let's get started with the micro frontend itself. In my case, the micro frontend is a traditional Angular application. It could also be a traditional React application, Vue application, Svelte application, or something else. Nothing special in here, nothing special but this Webpack config. This could be a fully blown Webpack config. In this case, it's just a partial one, because the Angular CLI is creating the rest. And this partial Webpack config just gets some key data, like a unique name for this micro frontend. MFE1 is my not that creative name. Then I need to define what to expose. And I'm saying, hey, let's expose Honda flights module, which is an Angular module. It could also be a component or a function or something else. Everything that can be expressed with ECMAScript can be exposed here. And this is my alias, because the consumer does not want to remember this long path, so they can just go with module. Besides this, I need to define what I need to share or what I want to share. And normally you need an exhaustive list of all the packages you want to share. However, as I have found out, maintaining an exhaustive list can be quite exhaustive. And so I'm going with a helper function here. I'm calling it share all. Share all looks into your package JSON, and then it is just sharing all the packages in there. This makes it easy to get started with module federation. However, if you want to skip something from being shared, like let's say Angular common testing, you don't need testing libraries at runtime, you can put it here into a skip list. It's just a convenience function that makes everything a bit easier. Okay, this is my Webpack configuration. This is everything I need to add in order to get started with module federation. And this alone makes a micro frontend out of my traditional Angular application. It's really that simple. Now let's go on with the shell. If we look into the shell, we see the same. A traditional application plus a webpack config. And in there, we also have some key data. Normally, we would define some remote mappings, some URLs pointing over to another micro frontend. However, in this demonstration, I'm going with a more dynamic approach. I don't want to hard code this URL here in my webpack config. Yeah, it would be really hard coding, even though it's a configuration file, because, you know, the webpack config is only used during the build. Webpack is a build tool, and so with this setting here, it would not be possible to exchange this URL afterwards. And so I'm going with a more dynamic approach. That's why I commented this out. Besides this, also the shell needs to define what to share. Sharing is always an opt-in thingy. Everyone needs to opt in order to get something shared. Just think about sharing your dessert with me. If I want you to share your dessert with me, I need to opt in. Don't worry about this, but also you need to opt in, because otherwise it's not sharing if you don't opt in. Otherwise it's theft. And we want to prevent something like this. It's not considered to be polite. Okay, so make sure you have a similar share configuration in all your bodies to make something really shared across all of them. Besides this, my application here is a traditional Angular application. Of course, when bootstrapping my Angular application with the main DS, I need to call Angular. And this is now postponed by placing it into the bootstrap file. At first glance, this does not make any sense. I have here an import, and I have here my bootstrap file that is just imported, and this bootstrap file is loading or bootstrapping Angular. At first glance, this does not make any sense. However, this is a common pattern in the world of module federation. It's really a common pattern. This first import makes your module federation to initialize itself. It makes it to find out about other micro frontends, to discover other micro frontends. And after discovering them, it knows about all the shared versions. And so it can decide which shared version is loaded from where. As we will see in some minutes, it might decide that it takes Angular from here and perhaps RxJS from there. There might be a good reason. Perhaps here we have the highest Angular version and there we have the highest RxJS version. But in order to do something like this, in order to do a decision like this, it needs metadata. And this metadata is loaded and evaluated when we first import something that needs the shared libraries, like my bootstrap does. That's why we need this strange looking indirection. As mentioned, it's a very common pattern in the world of module federation. Besides this, we are doing what we do all the time. We are bootstrapping Angular here. If you are a React person, you would bootstrap React. If you are a Vue person, you know, and Svelte and so on. Then there is the moment of truth. And the moment of truth comes with lazy loading. If we want to lazily load something from over there. For this, you need some kind of lazy loading configuration, which is here in Angular, my routing configuration. If you lazy load something with the router, normally you have a path that is using an import like this here, an import that is loading something on demand. And as seen before on the slides, we could totally go with such a dynamic import. However, here I want to have everything a bit more dynamic, and so I'm going with this helper function. It's not really necessary to have a helper function. Import would be good enough, but it makes everything a bit more flexible. The main point is, and I think most people don't see this, the main point is this string here is very often compiled directly into your bundle. Depending on your bundler, it's not possible to exchange this string here because it's an integrated part of this import statement. And so exchanging the string would become quite difficult. However, if you do the same with a helper function like load remote module, you can easily exchange all the key data like the name module or the URL, which points over here to my other micro frontend. We could totally get this from a service in the backend or from, let's say, a JSON configuration file we load when bootstrapping the application. By the way, if you wonder what type is doing, type is telling us, hey, this target is an ECMAScript module. Angular is meanwhile fully using ECMAScript modules. If you have another framework, you might want to go with script. This means it is just an ordinary JavaScript file. Yeah, and that's it. You don't need more. You just grab over, you load something from over there. In my case, it's the export or exported flights module. That means every time we are triggering this route here, this module will be loaded and this module will come with its very own components. Like this here that is within the red dashed border. It's really as simple as that. However, when talking about sharing libraries, I heard you thinking. I heard you thinking through Zoom and through all those remote technologies that sharing code, sharing libraries might lead to conflicts. Like DLL hell in the world of Windows. We had something like DLL hell where you register different versions of the same DLL. They were replacing each other and so your applications crashed. And here we might have the same situation. Perhaps one micro frontend needs Angular in this version and one micro frontend needs Angular in that version. And this might make everything crash. Well, the good message is, and this is my first real topic for today, after my 101, module federation is really good at dealing with version mismatches. It has several strategies for dealing with them baked in. And even the default behavior, if you do not configure anything, is quite smart. It's about selecting the highest compatible version. The highest compatible version, what a term. Well, if you think about what this could mean, let me show you an example. Let's say someone has version 10 of something and someone else has version 10.1. Now, according to semantic versioning, the highest compatible version is 10.1. According to Semver, it should be backwards compatible to 10. And so only 10.1 is loaded. And everyone who needs 10 is also getting 10.1. And this explains why we need this metadata, why we need this dynamic import that underneath the cover looks at all the metadata and decides where to load which library from, like Angular from here and perhaps underscore from there. However, there is a little tiny pitfall. You have to think about internal framework APIs. Let me give you another example for this. Think about compiling your application with the Angular compiler. In this case, the compiled version of your application is accessing the private API, the internal API of Angular. And there are no guarantees for the internal API in terms of semantic versioning. So in general, you have to make sure that your Angular-based code sees exactly the same version of Angular at runtime as it was built with. Because the compiled code is using the internal API, and the internal API even might change from minor to minor version or from batch to batch version. There are no guarantees. And this is not really an issue of Angular. I think it's an issue of all the frameworks that are using somehow internal APIs of libraries in the neighborhood, like a framework that consists of two packages that are communicating with each other using the internal API, or a framework that comes with a compiler, which is quite common nowadays. Think on Mako, think on Solid, think on Svelte. All those frameworks have a compiler. And so chances are that the compiled code is accessing private parts of the framework. That means don't use special characters like the root, like the rooftop, as we call it, the rooftop or the tilt, because in this case, you tell Webpack in general Node, but also Webpack, that you are fine with a higher compatible version. Don't use the special characters in your package JSON. And so Webpack will assume that you want to have exactly the version you have used and that is mentioned in your package JSON. So please keep this in mind if you go with frameworks. This is not a big deal for libraries like underscore or RxJS, but libraries that use a compiler or communicate with internal APIs with other libraries have this issue. Yeah, otherwise it would be too easy, wouldn't it? So perhaps you have another situation. Perhaps you have the situation where you don't have something like a highest compatible version. Let's assume you have 11 here and 10.1 there. So according to SEMVer, semantic versioning, there is no highest compatible version. 11 is not necessarily backwards compatible to 10.1. And so in this case, without any further configuration, Webpack module federation loads both of them. And of course, this is a hit on your bundle size, but perhaps bundle size is not that important for you. Of course, if I ask you, is bundle size important for you, then it's almost a leading question, is it? No one would say, no, it's not important. The real question, by the way, here is, how important is it compared to other goals you have? How important is it? And that means you need to know about your architectural goals and you need to bring them in an order. And only if you have this order, you can decide if someone else, like having autonomous teams that can work on their own and publish when they are done, is more important than bundle size. You really need to evaluate this. I have seen a lot of applications where bundle size is not that important, where people told me, well, we can afford to load several versions of the same library, especially if we do it in a lazy way. Of course, if you are building a web shop, a public portal, something where conversions matter, something where you want to sell something, then the bundle size is really fundamental. And then you want to avoid something like this. But I think the main takeaway here is it depends on your style of application. You really have to evaluate it against your architectural goals. There is another configuration setting that is quite nice. I call it the Highlander principle. Perhaps you know the 90s TV show, The Highlander. The slogan was, there can only be one. And this is the case here when we talk about a singleton. There can only be one. So if you configure your library as a singleton, only one version of it will be loaded at runtime. It's the highest known version. So if the one micro frontend comes with 11, another micro frontend comes with 10.1, then only 11 will be loaded, regardless if it is backwards compatible or not. Just this version is loaded. And perhaps this is okayish in your very case, or perhaps this makes the whole application crash. Hopefully you have some integration tests making sure that this works. And also in this case, because it's a bit dangerous, you get a warning on your console. Like, hey, do you really know what you are doing here? Perhaps this will crash. Perhaps it works, no one knows, but no guarantees. You get a warning on your console. Yellow letters on your console. If you don't want to have yellow letters, if you want to have an exception, a hit into your face, then also set strict version to true. Then you get immediately an exception when you start your application. It's a bit more rough, yeah, but I really like this because this allows me to fail fast. And failing fast is something I want to do in my integration tests. I want to quickly find out that something is not working here, that we have an issue, so that I can deal with it, so that I can make sure we have the same version everywhere, at least a compatible version everywhere. So my recommendation would be try to fail fast. Plus, obviously, you need a sound set of integration tests. This is for the very brave of you. So if you don't know any fear, then this is what you want to do. This is about relaxing your requirements. You can say, well, I know it was compiled against version 10, but hey, I'm an expert. This will work with everything within this version range here. And like with a typecast, you are taking responsibility. If you are right, you might be the hero. But if you're not right, then the application crashes and then it's your fault. So don't blame Backpack here. I think this is nothing for an everyday usage, but sometimes if you need to tweak a little tiny bit, if you have an issue with version ranges and compatible versions, and if you say, well, this is good enough, then this could save your day. But use it with care. You know, with great power comes great responsibility. The thing is, and I think you have seen this so far, there are several baked-in features for dealing with version mismatches. However, if you ask me, the best strategy to deal with version mismatches is to avoid them. And there is one strategy you can apply to avoid such conflicts upfront. It's about going with a monorepo. And yeah, I know there are a lot of emotions in there when we talk about monorepos versus multiple repositories. But funnily, both works. I've seen both working out there in the wild, even though there are flame wars telling you that perhaps just this or that works. No, both works. However, both has different consequences. And this is what software architecture is about. Software architecture is mainly about thinking about and dealing with consequences. Which consequences do I prefer? Consequences are always both positive and negative. There are always positive ones and negative ones. The main question is, which consequences are more beneficial in your case? So if you want to have micro frontends by the book, micro frontends as they have been envisioned originally and described originally, you would go with multiple repos. Multiple repos allow you to have a strict isolation between your micro frontends, namely the borders of your repositories. They isolate the micro frontend strictly. It's not easily possible to grab over those borders. And so you cannot easily intermingle your micro frontends with each other, which is important because you want them to work in isolation. You want to implement them separately and deploy them separately. And that means because of having those strict borders within your vertical, you can do what you want, almost. You can decide on your architectural style. You can decide on your framework, like going with React here and Angular there. You can decide on your version, like going with Angular 15 here and already trying out Angular 16, which is shipped in some hours, I guess, there. So you have the highest amount of flexibility, the highest amount of flexibility. Of course, the big question is now, where's the catch? And the catch is, nowadays, we talk about micro frontends, don't we? And we also talk about single page applications. And having a single page application means all of this code needs to be downloaded into the browser. Not at the same time, but eventually when we talk about lazy loading. And my theory is downloading several versions of the same framework or different frameworks is not necessarily decreasing your bundle sizes. So one more time, you have a hit on your bundle sizes, plus you need to deal with version mismatches, which almost every time means that you need to bootstrap both versions separately. And there are no guarantees that this works. No one tested if Angular 15 runs in the same browser window together with Angular 16. No guarantees. It was not officially tested. However, you can make it work. The road is a bit rocky, but you can make it work because at the end of the day, we are talking about JavaScript code that's downloaded into the browser. But it's a bit more rocky. And so I guess you will avoid something like this, a scenario like this, if possible. Another drawback here is you need to share your libraries via NPM. That means after each and every change, you need to publish your library. You need to, first of all, assign a new version and then publish it. And then you need to download it again and integrate it in your application. And with each and every bug fix, everything starts over again. But for this, you get the highest amount of flexibility. If you say, well, I don't need that much flexibility, and if you say, well, I don't want to deal with version mismatches, then you could go with a monorepo. One huge repository that allows you to enforce a one version policy. There is only one version of everything installed in there. One version of Angular, one version of React, one version of Vue. And so it's more difficult to end up with version conflicts. Also, you get more optimized bundles because your framework version only needs to be downloaded once. However, this also means you need to agree on one version number. You need to have processes for updating your versions. This is the downside here. But besides this, anyway, you can deploy your app separately. Even though they are part of the same monorepo, you can deploy them separately. That means you get some of the advantages of micro frontends, not all of them. You get some of the advantages, but also lesser disadvantages. So it's somewhere in the middle, and perhaps this is a good option for you. It really depends. As mentioned, I've seen both working out there in the wild several times. Both works, however, both has different consequences as discussed before. By the way, perhaps you're saying, well, yeah, I like the monorepo idea, but if everything is part of the same monorepo, everything is intermingled with each other. Because now I cannot avoid or not easily avoid this application from grabbing over there. And suddenly my domains, my micro frontends are coupled to each other, something I normally want to prevent when going with micro frontends. And the answer here is, yeah, but you can go with linting. You can define linting rules, preventing someone from this micro frontend to use something from that micro frontend. There are several linting tools out there. For instance, the tool NX comes with such linting rules that allow you to define access restrictions between your parts of your monorepo, parts, business domains, verticals, micro frontends, as you want to call them. This is how it would look like. Here, it seems like I'm in the boarding part, in my boarding micro frontend, and obviously I try to grab over to the booking micro frontend. And now NX tells me, hey, Manfred, what do you think you are trying to do? You are in boarding, and that means you are only allowed to access boarding and some shared libraries, but not booking. So this can be easily compensated with linting rules. Besides this, as mentioned here, you need processes if you want to update your dependencies. Yeah, as mentioned before, NX is quite a nice tool set for a lot of things you normally need when you want to go with a huge mono repository. And one of those features is those linting rules. By the way, it's available for a lot of frameworks out there. Okay, so let's also talk about dynamic module federation. Sometimes you don't know about your micro frontends upfront. And for those situations, you have to get rid of this remote section here. You cannot map it upfront. And then you've seen it in my example before. Instead of going with an import, you need a little tiny helper function that talks with module federation at runtime. Yeah, module federation is there at runtime. There are some objects in the global namespace if you compile your application with module federation. And I think we all know what I'm referring to when using the term global namespace. So this helper function is talking with those objects and grabbing something from over there, a component, for instance. Let's have a look into a demonstration for this. So as seen before, I'm already using this helper function, and so I can easily switch out those strings. However, still, this is one routing configuration. And the routing configuration is defined when the application bootstraps. That means squeezing in here additional routes I was not aware about during the compilation does not work. The good message is with Angular, and I assume it's the same with a lot of other frameworks, there is a way to dynamically configure the router. For this, let's get rid of this configuration here. And then let's move to my app component, my main component. And here I've prepared some example code. Some example code that sets up its own additional routes. Let's imagine we are reading some configuration file or perhaps some configuration data coming from a service in the backend, a RESTful service that tells us about that today we have this and that and those micro frontends over there. Then I could take this configuration data and tinker a data structure that acts as a configuration for my router. I think we all can imagine that a data structure like this can be made out of a configuration object we received from the backend. And then we can merge this configuration data with my static routes. Routes I always have, like a route for the home component or for the about component or for the settings component. I merge both together, and then I'm telling my router, please reset your configuration. Please now use my combined routes, the dynamic ones and the static ones. Also, I think we all can imagine that with the same metadata, it would be quite easy to render those hyperlinks in a very dynamic way. And so We get the hyperlinks and the opportunity to navigate to micro frontends we did not know at compile time. Now in a very dynamic fashion. However, the main question quite often is, how can we accomplish to mix and match several frameworks or versions? Something I'm referring to as the Frankenstein architecture. It works, but it can be dangerous. We all know the story with the Frankenstein monster. It did not end that well. Up there at the North Pole, it was a disaster at the end. However, the thing is, you can make it work. You can make it work if you really need it. The road towards this, however, is quite rocky. If you want to mix and match several versions, you could first of all load a component from another application. However, instead of directly loading the component from a different application, perhaps an application that was built with a different framework, you could just import the main file of this other application. You know, most of the single page application frameworks have a main file or an index.ts file that has a bootstrap function. And then you call this bootstrap function. And this just is bootstrapping another single page application in the middle of yours. That means you have another single page application as part of your single page application. However, if you bootstrap a single page application, you need some root elements, some elements the bootstrap function is looking for, some elements the bootstrap function is putting the application into. And such a root element could be created in a dynamic way with 20-year-old DOM magic, document create element. Perhaps you find out that you don't need to call the bootstrap method, because very likely your main TS, your index TS, place your name, is self-bootstrapping. Normally, it calls the bootstrap function of your framework. And then perhaps you want to wrap those 3 lines of code into a component built with your very own framework, with the framework of your shell. And this allows you to route to this or that separately compiled, separately deployed, separately bootstrapped application. Now my Angular application can navigate to a React application and a Vue application and all the other applications out there. Is this really that easy? Well, yeah, the road is a bit rocky. It's not officially supported. No one tests if framework A works together with framework B, but at the end of the day, you can make it work. At the end of the day, we are talking about JavaScript code that is loaded into your browser. Obviously, if you don't need this, you would avoid such a architecture and hence the complexity that comes with it. By the way, some of the workarounds you need for something like this have been implemented with this little tiny NPM package. And if you go down this rocky road, the result is really amazing, because suddenly you get the best of both worlds. Suddenly you can have different frameworks and framework versions, because everything is hidden behind web components. So the browser does not even recognize that several frameworks and versions are used. But if it happens that 2 or more micro frontends use the same version in the same or the same framework in the same version, they can share it because you have module federation. So if possible, the library is shared. If not possible, because you need a different version, it's not shared, it's loaded one more time. So let me show you all of this in action. Let's move over here to my dynamically created routing configuration. And let's go with this special route here. It's a route that points to my web component wrapper. The web component wrapper takes this key data. In Angular, each and every route can have a dynamic object. Data is just a dynamic object. You can pass in everything you want. In this case, this data is exactly what module federation needs in order to load something from over there. An URL, a remote name, and an exposed module. And this exposed module is by coincidence here a web component. This web component is loaded. And then this web component wrapper is adding an element with this name. An element called React element. And you know, a web component looks for its host element, and when present, it renders itself in there. And that's it. So you can easily load something from over there, a web component, using module federation. Because of going with module federation, you can easily share libraries. And then this web component will be bootstrapped in this element. That's it. By the way, this web component here could have a router of its own. But also our shell has a router. And so I'm going with a special routing configuration here that makes the router just look at the beginning of the route. Every time a route starts with React, I'm navigating to this route. That's why I have this starts with matcher. The starts with matcher is not looking at the remaining segments because chances are high the router in there, in this case, the React router, looks at them and displays this or that subroute with respect to them. Yeah, that's pretty much it. Let's have a look at my example. Let's go to surprise, and hey, we've loaded, I'm very sorry for the React people, a React 17 application. I know it's not the newest version, but I think it's good enough to show that it would be possible to load another framework and or another version. I have another demonstration here in the cloud. This runs on Angular 14. This micro frontend is using Angular 14.2, so I just need to load the source code of this micro frontend. Here I'm using React 17, so I have to load the source code of the micro frontend plus React 17. Here I'm going with Angular 12. That means I need to download Angular 12 and the source code of this Angular application. However, here and there, I'm also using Angular 12. And because of loading everything with module federation, Angular 12 is only downloaded once. It's only downloaded once and shared during runtime. So if the version matches, we use the existing one. If it does not match, then we load another one. Here I'm even going with subroutes. And so it's important, you see it here, that the shell is only looking at this segment in order to load Angular C or Angular 3. And then Angular itself is looking at the remaining parts like /A or /B. Here I have a Vue application. Here I have Angular.js. And here I have something you might want to avoid, because for this Vue, we suddenly need to download 1, 2, 3, 4 frameworks. It's very likely nothing you want to have. If possible, I would recommend to integrate your micro frontends on a per route level. This would be possible, but this means you have to download all those frameworks, and perhaps those components need to interact with each other, and this creates a contract between your components, which also makes everything more difficult. One component could make other components fail. So if possible, integrate on a per route basis. Perhaps I should close Outlook. Okay. So if you like this presentation, there is more. There is this free ebook. Meanwhile, we have 12 chapters and it's the 5th edition, and you can download it for free here. So if you like this talk, download it here. If you did not like this talk, download it anyway. Perhaps I'm better with writing than with speaking. Who knows? Okay, let me sum up. We've seen that there are several baked-in strategies for dealing with version mismatches. Module federation is really good at dealing with mismatches. However, the best strategy is to prevent them upfront. And so you might want to go with a monorepo. Of course, it's a trade-off. If you go with the monorepo, you have some of the advantages of micro frontends. Perhaps you can deploy separately, but you restrict yourself a bit to don't get all the disadvantages. If you have multiple repos, you go all in with micro frontends. You have a lot of freedom, but this freedom might be costly. The Webpack Runtime API allows you to talk to Webpack during the application runs or when the application runs. And this allows you to load something you have not been aware of during the startup of your application. And this allows for very dynamic scenarios. And the Frankenstein is possible. It's a rocky road, but if you really, really need it, you can make it work by bootstrapping several single-page applications. I would wrap them into web components to abstract the differences between different versions and frameworks away. And if you, in addition, go with module federation, you can share versions if you have the same version in 2 or several micro frontends. And that's pretty much it. Here you find my contact data. Feel free to follow me on Twitter to stay in contact. And I've also uploaded my material to my blog. You find it here.